The timestamp reads a 3:14 a.m. when the submarine's camera feed flickers, and for exactly 11 seconds, the crew of the research vessel Peregrine sees something at 6,000 meters beneath the Bermuda Triangle that none of them will fully explain, even years later. Not a glitch, not a shadow, not a school of deep-sea creatures distorting the lens. Something else. And nobody on that boat was prepared for what the footage actually showed. Most people think they know the Bermuda Triangle. Planes disappear, ships vanish, compasses go haywire. But the version of this story you've been told leaves out the parts that are genuinely, scientifically disturbing. The part that mainstream coverage glosses over. The part that makes researchers go quiet mid-sentence when you ask the wrong question. This isn't a story about folklore. This is a story about a camera, pointed at the bottom of the ocean, capturing something that has no business being there. The Bermuda Triangle spans roughly 500,000 square miles of the North Atlantic Ocean, a region loosely bounded by Miami, Bermuda, and Puerto Rico. Officially, the United States Coast Guard does not recognize it as a uniquely dangerous zone. Insurance companies don't charge extra premiums for ships crossing it. And yet, the disappearances are real. Flight 19, a group of 5 U.S. Navy torpedo bombers, vanished here in December 1945 during a routine training exercise. All 14 men, gone. The rescue plane sent after them, also gone. The USS Cyclops, a 542-foot Navy cargo ship carrying 309 crew members, disappeared in March 1918 without sending a single distress signal. No wreckage, no bodies, no explanation. Skeptics have spent decades trying to explain all of this away. Methane gas eruptions, rogue waves, simple navigational error. And some of those explanations have merit. But, and this is the part that gets Buteau's ride, none of them account for what happens at depth. None of them address what lies on the ocean floor beneath one of the most anomalous stretches of water on the planet. Because until recently, we simply hadn't looked. Not really. Not deep enough. In the spring of 2023, a team of deep ocean researchers quietly departed from a port in the Bahamas aboard a vessel that most people have never heard of, carrying equipment capable of descending to depths where sunlight has never existed and pressure would crush an unprotected human body in less than a second. The vessel was the Peregrine, a privately funded research ship contracted through a consortium of oceanographic institutions, including affiliates connected to the Laboratorio de Oceanografía Profunda in Rio de Janeiro and a technology partner based out of Woods Hole, Massachusetts, one of the most respected ocean research facilities in the world. The mission, officially, was sediment mapping, studying tectonic activity along a deep subduction zone that runs beneath the Western Atlantic. Routine science, nothing that would make headlines. But Dr. Amara Nascimento, the expedition's lead researcher, had a secondary objective she'd been quietly pursuing for 3 years. She believed, based on acoustic imaging data collected during a 2019 survey, that there was something unusual on the seafloor in this specific corridor. A formation that didn't match the surrounding geological profile. Something the 2019 data couldn't resolve clearly enough to identify. So the Peregrine went deeper. The ROV, a remotely operated vehicle equipped with 4K camera arrays, sonar mapping systems, and acoustic sensors, began its descent at 11:40 p.m. on a Tuesday. The team watched the feed from a monitoring room aboard the ship. At 1,000 meters, darkness, as expected. At 2,500 meters, water temperature dropped to near freezing. At 4,200 meters, the first anomaly. The sonar returns started behaving strangely, not malfunctioning, behaving, as if they were bouncing off surfaces that the geological charts said shouldn't be there. Dr. Nascimento noted it in her log. The team adjusted the ROV's heading slightly and kept descending. At exactly 5,987 meters, close enough to call it 6 kilometers straight down, the camera captures something that Dr. Nascimento would later describe in a published log entry as, and these are her words, geometrically inconsistent with any known geological formation in the Atlantic Basin. The feed shows it clearly, a surface, vast, dark and flat, interrupted by what appear to be angular protrusions rising from the sea floor. Not jagged, not random, angular. The kind of angles that don't occur in nature without a reason. The ROV moves closer. The camera adjusts its exposure, and then, for 11 seconds, the feed captures the full scope of what's sitting on the bottom of the ocean beneath the Bermuda Triangle. The crew goes silent. Not the kind of silence that comes from confusion, the kind that comes from understanding and not knowing what to do with it. Here's where the scientific community splits into two camps, and the divide is far more revealing than the footage itself. The first camp, the larger, louder one, reaches immediately for geological explanation. Basalt formations can produce unusually flat surfaces. Hydrothermal activity can create crystalline structures with surprisingly regular geometry. Underwater landslides can stack sediment layers in ways that appear, at a glance, almost architectural. Dr. Renata Souza, a marine geologist at the Universidade Federal Fluminense, who reviewed still images from the footage, told a Brazilian science journal, "Unusual morphology at those depths isn't unprecedented. The deep Atlantic has surprised us before. That's true. It has. But here is what that explanation doesn't account for. The acoustic data recorded simultaneously with the visual feed shows something that no geological formation produces. A low-frequency resonance, pulsing at irregular intervals, emanating from within the structure, not from the water column above it, from inside it." Dr. Marcus Velho, an acoustic oceanographer with 17 years of deep-sea research experience, analyzed the frequency data and stated, publicly, in a conference paper that received almost no media attention, "The resonance pattern recorded at this site does not correspond to any known geological or biological source in our existing database. It is at present unexplained." Unexplained. That word does a lot of heavy lifting in oceanographic science. It usually means, we'll figure it out eventually. But sometimes, it means something else entirely. The magnetic field readings at that depth were also off. Not dramatically. Not in a way that screams headline, but consistently, measurably deviant from what the regional baseline should be. Magnetometers aboard the ROV registered fluctuations that the expedition report described as localized and source-specific, meaning the disturbance wasn't coming from the Earth's field generally. It was coming from that location specifically. 3 separate instrument systems: visual anomaly, acoustic anomaly, magnetic anomaly, all concentrated in the same place. And here's where the story gets very quiet, very quickly. But here's something that quietly slipped past almost every major science outlet. Within 72 hours of the Peregrine returning to port, 3 separate government agencies had formally requested copies of the raw footage, not the edited expedition highlights, the raw footage, full resolution, with all acoustic and magnetic data files attached. Now, that could mean nothing. Government agencies monitor deep-sea research regularly. It's standard procedure for operations conducted in certain international waters. That is the official explanation. And it may be entirely accurate. But Dr. Nascimento's team was also reportedly asked to delay publication of their preliminary findings. Not forbidden. Asked. By whom? The expedition report doesn't specify. For how long? Also unspecified. What we know is that the findings, which should have entered peer review within months of the expedition's return, did not appear in any scientific journal for over a year. Why? And why? And a version of the footage did finally circulate among researchers. Were certain frames missing? Not corrupted. Missing. Cleanly removed from the sequence, as if they'd never been captured. What was in those frames? We don't know, and that absence, is its own kind of answer. What the camera actually captured, when you strip away the geological noise, the acoustic interference, the official language, is a structure approximately 400 meters across, with right angles. 400 meters. To put that in terms that land properly, that is larger than 4 American football fields placed end to end. Sitting on the floor of the ocean, beneath the Bermuda Triangle, at a depth no unprotected human being could ever reach, and it has right angles. Nature does not make right angles, not at that scale, not with that consistency, not accompanied by internal resonance and localized magnetic deviation. The implications: if the footage is authentic, if the data is accurate, if the acoustic readings mean what they appear to mean, are the kind that don't fit neatly into any existing scientific framework, which may be exactly why the framework is being adjusted rather than expanded. What built it? When? And why? Of all the places on this planet, does it sit directly beneath the most mysteriously storied stretch of ocean in human history? So here's where I leave it with you. 2 possibilities. Either the deep ocean beneath the Bermuda Triangle contains a geological formation so unusual that 3 government agencies, 1 research team, and a year of delayed publication all converged on it by coincidence. Or something else is down there. Something that has been there long enough that the ocean built itself around it. What do you think? Leave it in the comments. I read every single one. And if this investigation unsettled you even slightly, wait until you hear what sonar surveys near the Nazca lines have started returning. That video is coming soon, because the truth is always stranger than the story we were told to believe.